Hello, dear students. Welcome to the channel and very welcome to this playlist in which we are discussing about the different applications of signals and systems based on Internet of Things or IoT. And today we are going to discuss one of the very important and very popular aspect of it. We are going to learn about Arduino. We are going to know what Arduino exactly is and for what different things it is used. So up until now we have seen, just for information, up until now we have seen uh, so many different things in this playlist. We have discussed about sampling, reconstruction, quantization, A to D conversion. We have also discussed about interpolation. We have discussed about different types of interpolation, sampling theorem, and how the whole quantization process holds up altogether. After that, talking about Internet of Things, we have discussed in previous two lectures about Internet of Things. We have discussed about what exactly Internet of Things is and how does it work. We have seen the different characteristics of Internet of Things, and we have discussed so many vast applications of IoT, including so many different sectors, so many different devices. Then we have discussed about, in very previous class, we have discussed about the architecture of IoT, how the IoT is built. And in that architecture, we have learned that IoT is, where the role of sensors and actuators is very vital in the IoT. So we have learned about different type of sensors that are used in IoT application and different actuators that are being used in IoT applications, and we also classified them. We have also seen the physical design or physical structure of IoT, and that's how far we have seen. So you're all caught up now. So today we are going to discuss about Arduino. By the way, if you want to check out all those stuff about IoT, you can click on the I button. It will be flashing on the top right hand side corner of your screen, and you can go and check out the whole playlist. Now coming back to the Arduino. So what basically is Arduino? Because you might have heard from your friends or few peers who says that Arduino is basically a software. Some of them says Arduino is basically a hardware. So what is it? So Arduino is basically both of them. Arduino is a software and a hardware altogether. It's an open source electronic platform which is based on easy to use hardware and software. Right? Allow me to explain. Arduino comes with a board. So this is the hardware of Arduino. Not exact hardware because Arduino has so many different boards. This is just one of them. This one which is you are looking at is called Arduino UNO board, and there are so many more just like that, just like this board, and we are going to discuss about them as well, not in detail, in very brief, but we will. So this Arduino boards these Arduino boards are able to read inputs, so many different inputs like a light on the sensors, or your finger on the fingerprint sensor, or a button, and it can even tweet for you if you want to. So it takes in signal and turn that signal into an output. It can activate a motor, turn on LED or an LED, and it can even publish something online. So you can ask your board to do whatever you want to do. And how do you do that? So you can send the set of instructions to the microcontroller, uh, which is fitted on the board here. Here, this one is the microcontroller here. And to do so, you can use the Arduino programming language and the Arduino software, which is based on processing. And today we are going to discuss about the Arduino hardware typically, and In next class, we will discuss about the software as well. So, talking about the hardware of Arduino, talking about the Arduino boards, over so many years, Arduino has been brain of thousands of projects, from everyday objects to complex scientific instruments, so many of them. And Arduino has grown so much now that it has its own community, right? A worldwide community of makers, students, hobbyists, artists, programmers, and even the working professionals all have gathered around this open source platform, and their contributions have added up an incredible amount of accessible knowledge uh, that can be great help for students like you, or even the experts, those who want to do research about control or uh, IoT itself. So what is it that makes the Arduino unique? Why everyone is using it? Why everyone is so hung up on it, so stuck on it? So one thing that makes Arduino unique is that it provides not only boards, but it also provides various other electric kits like sensors, robotic arms, meters, and many more. And that makes it easy to use, right? It makes it easy, and it makes easy to assemble the devices quickly. So in IoT applications, Arduino is like king. It is used almost everywhere. It also provides very wide variety of boards for different applications, and some of these boards can also come in small sizes. You can have the boards which are in the large sizes or giant boards, and there's a lot of stuff like that. Except for that, there are so many other applications of Arduino as well. You can see there are so many pins here. The Arduino has so many number of pins. With the help of these pins, you can connect different sensors or whatever you want to connect with it. And now that you are well aware of the board, Arduino board, not actually well aware, but aware of Arduino board in some manner, now let's discuss about all these pins. What are these pins and why they are used in Arduino, right? So let's see the next slide. We have the pins of Arduino over there. So before we go to the pins itself, it's good to understand different things which are bought on board to get the Arduino work, right? So first of all, you will be able to see this giant USB connector. So with the help of this USB connector, you can connect any USB, any pen drive to your Arduino Uno. Pretty much straightforward. This one is the power button. So it allows you to connect the supply and power on your Arduino. It allows you to turn on and off your Arduino in a way, right? Then here you can see reset button, and pretty much straight reset button is used to reset the Arduino. We have ICSP pins here. We have the power LED indication, which indicates that the Arduino is in on state. We have TX and RX LEDs. We will come to that eventually. We have analog and digital input output pins. We have input voltage and ground pins, and the reset pin as well. And we have analog reference pin and crystal oscillator as well. Now let's discuss about each of them in a little bit specific detail. And by the way, before I come and discuss this pin diagram of Arduino, let me tell you that you can interface different sensors and actuators with Arduino board, and you can build different projects on it. So Arduino board could have different type of microcontrollers connected to it. So this one is having this microcontroller here, which most probably would be at Mega 2530. I'm not sure though, but it would be a, for for the most part, um, I can say that it would be at Mega 2530. Then the latest controller which is used recently, which is not in this board eventually, is at Mega 328P, which is used in latest boards. Now let's come to the pin diagram and let's see the different pins which are used in the Arduino. So the first pin which I would like to talk about would be the input output reference pin, or IO ref pin, which earlier used to come over the reset pin here. Now they have, I think, shifted somewhere else, or they don't use it anymore. Okay, they do use it, but they've given somewhere else, probably here, right? So probably not present in this Arduino, but here you can see in this Arduino, here we are having IO ref, which is input output reference pin. Right here you can see around my cursor. So that pin provides the logical reference voltages for um, shields that use it, and it is connected to my 5 voltage bus. Right here, here also you can see input output reference. Then of course we have the reset pin, which does the same operation as the reset button. It resets your Arduino. And here you can see we have color coded different, not we actually, the credit to the owners of photo arduino.cc, but they've color coded this whole uh, pin diagram, and based on that you can see reset is a power, as well as here AVR set, or or analog voltage set. Then we have 3.3 voltage, which is basically a power supply. 3.3 voltage pin, power supply. Then we have 5 voltage pin. It is also a power supply. Uh, no gases here. Then we have this pin called G and D. Basically it is a ground supply. So basically it is a ground pin, and you will find 6, or total 6, which means 5 more pins which look like that. In old Arduinos we used to have 6 pins. Now they have reduced the number of ground pins to around 3 or 4. So now you can see here 1, 2 and 3 here. Okay, so in latest digital Arduino Uno you will be able to only see 3. Probably you will be able to see more in the old, right? So total they used to have 5 to 6 ground pins, which are all of course are interconnected. Then we have V in pin, which is um, used to power the Arduino Uno with the external power source. And all these pins which I've talked about are power supply pins. Then come here and see we have A0 to A5 pins, which all of them, see here, A0, A1, A2, A3, A4, A5, which means total 6 pins, and all of these are analog input pins, which utilizes analog to digital converter, or ADC converter. And these pins serves as analog input, but it can also serve as the digital input or digital output as well, right? So here you can see that we have not we, but they have assigned analog and digital, right? So it can serve as analog pin as well and digital pin as well. Then we have a ref, which is basically analog reference pin. which you can see here is it is also basically a power pin. Then we are having the ground pin, we've discussed about it. And I will come to TX and RX pins, but here we are having digital pins, which goes from pin 2 to pin 13 here. So all of these are digital input output pins, which can be used for any digital input or output. And you will see these kind of symbols around the third pin, fifth pin, sixth pin, ninth pin, 10th pin, 11th pin. See this symbol. So that symbols basically means the PWM capability, which means that particular pin holds the capability of pulse width modulation. Pulse width modulation is basically a modulation technique which is used to encode message into pulse signals, and it is used very much when we are doing communication with the help of different transistors, or like IGBTs, or even MOSFETs, right? So PWM we can use it. Then and you can see that they have said that it is a digital pin, it's also an average pin, and it is pin 2 and pin 3 are interrupt pins as well. They are used as an interrupt pin as well these days. And now coming to the final two pins, this TX and RX pins. So these are serial input serial output pins, or they can also be used as digital pins 0 and 1. As you can see, they have also been numbered as digital pins 0 and 1 here. So this TX and RS pins are serial pins. You can see TX RX here in the serial port. So these pins cannot be used for digital input output, but only for serial input output. And serial communication is used to exchange the data between Arduino board and another serial device. Like it can be any computer or display or any sensor, any such kind of device, right? And you will find each and every Arduino board having such different serial boards. So that was the pin diagram of Arduino UNO, and the sensors and actuators can be connected to this board as per this pin layout. And with the help of sensors you can do so many different operations, IoT operations you can conduct. But whenever you do so, please note that there could be difference in the pin layout, which based on the different type of boards you choose, or pin layout can be different in old Arduino Uno and new Arduino Uno as well, like I've told you, right? So whenever you do so, please read and understand the board pin layout first, and then also study the connection diagram very carefully before working with these boards, or else you might blow the board. In technical terms, you might damage the boards, and um, it can cost you a few dollars or few rupees. So we will keep this class brief, uh, and in upcoming class we are going to discuss about the programming in Arduino. So if you have any doubts, queries, questions related to today's class, feel free to mention them in the comment section below. Any kind of input from you related to channel, any kind of feedback related to channel or playlist is most welcome. So if you have any feedback, please mention them in the comment section below as well. I will see them, I will reply each and every one of them as soon and as quick as possible. And I will be seeing you next time with a new video which will discuss about the programming in Arduino. Till then, take care of yourselves. Thank you very much for listening, and goodbye for now. See you in the next video.